6.1 example 4, writing an exponential model when the initial value is known. In 2006, 80 deer were introduced to a wildlife refuge. By 2012, the population had grown to 180 deer. The population was growing exponentially, right? An exponential function n of t representing the population n of deer over time t. So let's start off with the very first thing. So 80 deer were introduced. So at time 0, we had 80 deer. So this is giving the point 0, comma 80. In wildlife, by 2012, the population had grown to 180 deer. So 2006 to 2012, now we're at time 6. So 6 years later, we have 180 deer. This gives us the point 6, comma 180. And I feel like we have enough information. So we're at an exponential function n of t. All right, let's use our equation. So n of t is equal to, let me see, our base, not the base. So our equation n of t is equal to a times b raised to the power t, where a is our initial condition. So at time 0, so n of 0, a times b raised to the power 0. Anything raised to the power 0 is going to be 1, so that eventually turns into 1. We have 80. So we have a times 1 is equal to 80, which tells us that a is equal to 80. All right, perfect. So far we have n of t is equal to 80 times our base raised to the power t. So we just used this this point. Now let's use this point. So now we have the equation n of t is equal to 80 times b raised to the power t. Now we're going to plug in that next equation, or that next point. N of 6 is equal to 80 times b, which is what we're looking for. And this time to the power 6, this is equal to 180. And now we have 80b to the power 6 is equal to 180. Let's divide both sides by 80 to get the base by itself. B to the power 6 is equal to 180 divided by 80. So 180 divided by 80, 2.25. And now to get b by itself, we could take the 6th root of this. Just in case you don't know how to plug that into your calculator, what you could also do is raise this to the power. Let's change the notation a little bit. We could raise this to the power of 1/6. Because nowhere in our calculator here do we really have, like, we have a square root calculator all the way on the end there, but we don't have an nth root calculator. So we could just use this instead of using the roots. So we have b is equal to 2.25 raised to the power of 1/6. And that gives us about 1.1444714. And let's see, did they give us a decimal place? So population grow, write an exponential function. No, they didn't. Let's just round out 4 decimal places to be safe. So 1.14471, so 7. And plug everything back in. We have n of t is equal to 80 times, we just found the base, 1.1447 raised to the power t. And that's our function. If you have any questions whatsoever, please feel free to ask. Otherwise, bye.